Let's look at insertion sort. So insertion sort is an algorithm that is a bit more efficient for small or nearly sorted data sets. And it basically works by building a sorted portion of a list to one element at a time. So how it works, we're going to just see quickly here how it works. So how it works. And the first step that we do when you're doing insertion sort is we start with the second element and then we treat the first element as the sorted. Yeah. So start with second element and treat the first element as sorted. So treat first as the sorted element, rather as the sorted sublist in this case. So after doing that, what you're going to do next is you're going to take the next element and compare it with the elements in the sorted sublist. So take next element. It should be x. Take next element and we compare it with the sorted sublist. Again, remember we had already defined a sorted sublist earlier. Then the next thing we're going to do here is we're going to shift the elements to the right until we find the correct position for the new element. So shift to right until okay. We're going to shift the elements to the right until we find the correct position. Until correct position. Then after doing that, the next obvious step from here is going to be to insert the element in its correct position since we found it. Insert element in correct position. So we're going to insert the element in the correct position, and we're just going to repeat this process until the entire list is sorted. Now, again, this process is going to make much more sense if you look at an actual list and how that would look like. So this is a list that we have, and the list is unsorted, right? So what we're going to do, we're going to start with 5, and we're going to basically assume here that 5 is, or we treat 5 as the part that is sorted. So we're going to treat 5. Okay, this should have been okay. So we're going to treat 5 as the part that is sorted, or as the sorted sublist in this case. Then we're now going to take 1. We're going to take 1 here, and we're going to compare 1 with 5. As you can see, we say we take the next element and we compare it with the sorted. So remember, this is the sorted. So we're going to compare 1 with 5. And then after comparing, we determine that 1 should be at position 5. So we basically insert 1 before 5. Then if we do that, our list is going to look like this now. Let me just copy paste and put it here, and I'm just going to reduce the size, and then even for this one. So how this is going to look like, we're going to have 1 here and we're going to have 5 there. So this is going to be the next what the list becomes after following after following the process that we followed here. Okay, I hope all this makes sense. Let me just do it again. So we just 1 comes before 5. Then this is what our list looks like, our new list. Then the next step we're going to do is we're going to move to 4. So we're going to move again, we move to the right. So we're going to move to 4. Then we're going to compare 4 with 5. Then we insert 4 in its correct position. So the correct position for 4 is going to be right before 5, right? Then we're basically going to have a new list. A new list is going to look like this. Let's have this as our new list, which is going to look like, now we have 1 here as we had, and then this is going to be 4 now, and 5 is going to be here. And this is what our new list is going to look like. And we're going to repeat the process again. So we checked for 4. Then the next element we're going to check for now here is going to be 2. Then we're going to repeat this process all through until the entire list is sorted. And the entire list sorted is going to be now 1, 2, 4, 5, and 8. And that is basically how insertion sort. That's how insertion sort works. Now let's see how you can implement this in code, and how you'd go about that. So we have our function here called insertion sort, and it checks in an array. It checks in an array as a parameter. So what we're going to do is we can start as we've been starting before by just checking the length of getting the length of the array. Again, this is a process that you can always just embed in the for loop directly instead of doing it there. But let's just do for I in range, then we're going to check from 1 to the length of the array, which in this case here we have as n. So it should be an in here. So for I in that range, what you're going to do after doing this is take every element at index, rather an element at index I. Then we're going to make this element the key. And then the next thing we're going to do is you need to get j, position of j. So j is going to be I minus 1. So j would be I minus 1. Then the next step we'll do is have another loop here. So we're going to check here while j is greater than or equal to 0. While j is greater than, should be an equal sign here. So while j is greater than or equal to 0, and the key is also less than the element at index j. So and key is less than the array element at index j. If that is the case, or rather while that is the case, we're going to go ahead and take the element that is at index j. So just do this. We take the element that is at index j, and we're going to store this as the element in array at index j plus 1. Index j plus 1. So we take an element. So again, not what our loop is doing. We're checking if j is greater than or equal to 0. If that is the case, and the key, that is the array at index I, is less than the array at index j. While that is the case, we'll take the array element at index j and basically replace it with store it in array at index j plus 1. Then the next step that we're going to do after this is we're going to basically subtract j by 1. So you can just basically add all this process all together. So you have j minus or equal to 1. Then finally, we're basically going to also have the key at ij plus 1. So j plus 1, we're going to have this as the key. And that is basically it. And then finally, the next thing we do is we just return the sorted array. And let's see how this would look like. So I'm going to print insertion sort, and we're going to give it an array. Let's give it our array. Again, our array is 51428. So we have 514, should be 4, 2, and 8. Now let's see if this is sorted. So we'll just say Python 3 insertion. Yeah, as you can see, it sorts our array, and the time complexity for this is also O of n squared in the worst case, but it can be more efficient for a list that is nearly sorted. This would be more efficient for that. So I'll just write it here. The time complexity for this is going to be O of n squared as the time complexity for this. But again, like you've mentioned, it's much more efficient when we're dealing with an array that is nearly sorted. Okay, thank you for watching this far. Next, we're going to look at some of the more efficient algorithms, starting with merge sort and going forward.